All right, let's talk about acing that next .NET interview. We're going to break down the core concepts that'll make you stand out from the crowd. Ready? Let's jump right in. I mean, let's be real for a second. Crushing that interview isn't just about cranking out code on a whiteboard, right? It's about proving you really get the whole .NET ecosystem, deep down. And that's exactly what we're here to do. We're going to build up that confidence by hitting the big pillars of .NET, from the absolute guts of the framework all the way to the modern stuff you'll use every day. Okay, so first things first, let's get into the .NET engine. This is the kind of under-the-hood stuff that interviewers absolutely expect you to know. It's the bedrock, so it's the perfect place to start. So what is .NET, really? At its core, it's this incredibly flexible, cross-platform framework. The big thing you want to remember for an interview is this. You can build pretty much anything. Web, desktop, mobile, you name it. And you can do it anywhere, with languages you're already familiar with, like C#. Okay, but how does .NET pull off that cross-platform magic? This is super interesting. Your C# code, it doesn't get compiled straight into machine code. Nope. First, it gets turned into something called CIL, that's Common Intermediate Language. Then, when you actually run the app, an engine called the CLR grabs that CIL and translates it into the specific machine code for whatever device it's on. That two-step process, that's the secret sauce right there. And that leads us perfectly to the CLR, the Common Language Runtime. Seriously, think of it as the heart and the brain of your application. It's not just the engine making it go, it's also the life support system. It's doing all the heavy lifting in the background, managing your memory, handling security, optimizing performance. It is, without a doubt, the core of everything. All right, now that we've got the engine down, let's talk about something that builds right on top of it, memory management. And listen, this is a topic that can really separate a junior dev from a senior in an interview. They love to dig into this stuff. So, in .NET, you're always going to hear these two terms, managed and unmanaged code. The difference is actually pretty simple. You just have to ask one question. Does it run inside the CLR? If the answer is yes, congrats, it's managed code. The CLR takes care of memory for you. If the answer is no, it's unmanaged, and suddenly you're on the hook for managing memory, which, trust me, is a whole lot trickier. So how does the CLR work its magic with memory? It's all thanks to a process called garbage collection. I like to think of it as a little three-step dance. First, it does a mark step. It finds all the objects your application is still using. Then it does the sweep. It gets rid of everything that wasn't marked. And finally, to keep things neat, it compacts the memory. So just remember, mark, sweep, compact. Easy. Okay, to go even deeper on memory, you have to understand the difference between value types and reference types. This is huge. A value type, think of something simple like an integer, is like a piece of paper with a number written on it. If you copy it, you get a brand new piece of paper. They're totally separate. But a reference type, like an object, is different. It's like a piece of paper with a map to a treasure chest. If you copy that paper, you just get another map pointing to the exact same treasure chest. And here's a perfect example of that. We've got a value type, an integer. We say A is 10. Then we make a copy, B. Now we change B to 20. What happens to A? Absolutely nothing. It's still 10 because when we copied it, we made a completely new independent variable. But now look what happens with a reference type. Totally different story. Here, P1 and P2 are just our maps, right? They both point to the very same person object. So if we use our P2 map to go change the name to Bob, we're changing the actual object. And that means if we check P1, guess what? Its name is now Bob2. Because, and this is the key, they both point to the exact same spot in memory. All right, great. We've covered the engine and memory. Let's shift gears now and talk about the architectural patterns that really drive modern .NET applications. This is the stuff you'll be working with day in and day out, and it's definitely going to come up in an interview. So check out this code snippet. See how the order service is creating a new payment service right inside itself? This is what we call tight coupling. It's basically saying, I, the order service, am now permanently welded to this one specific kind of payment service. And you might be thinking, so what? What's the big deal? Well, here's the problem. What if you want to test your order service without, actually charging a real credit card every single time? Or what if your company decides to switch payment providers later? With this code, it's a total nightmare to change.
The answer, my friends, is dependency injection. Look at the difference. Instead of creating its own payment service, our order service now just asks for one in its constructor. And even better, it's asking for anything that behaves like an iPayment service, an interface. This one change makes our code way more flexible, super easy to test, and a heck of a lot easier to maintain.
Next up, another modern must-know: async and await. They're what lets you do long-running stuff, like calling an API or hitting a database, without your whole application just freezing up. But here's the real nugget for your interview. When you await something, your code doesn't just sit there and do nothing. It actually releases the thread it was using so that that thread can go and do other work. That's the magic. That's how a web server can handle thousands of users at once.
And of course, we can't talk modern C# without bringing up LINQ. It completely changed the game for working with data. But there's a classic interview gotcha with LINQ, and it's called deferred execution. See that query on the screen? It doesn't actually run right away. Nothing happens until you try to use the results, like calling .toList or looping through it. Knowing this is so important for performance. Okay, we're on the home stretch. For our last technical deep dive, let's talk performance. Honestly, knowing how to optimize an application, that's a huge sign that you're operating at a senior level.
And one of the absolute biggest wins you can get for performance is caching. The main idea is super simple. You just store a copy of data that's expensive to get and doesn't change very often somewhere fast, like in memory. This stops you from having to go all the way back to the database every single time. And man, it can make your application fly.
So what are the best practices here? Well, for a simple app, in-memory caching is probably fine. But if you're building a big cloud application, you're going to want a distributed cache like Redis. But here's the most important rule. Always set an expiration time. You do not want to be serving up old, stale data. And this should be obvious, but please never cache sensitive user data. Just don't. All right, let's bring it all together. Think of everything we've just covered as your essential toolkit. This is what you need to walk into that interview feeling prepared and confident. Think about it. We started at the very foundation, the core architecture. Then we got into the nitty-gritty of memory management. From there, we jumped into modern patterns you'll use every day, like dependency injection and LINQ. And we wrapped it all up by thinking like a senior dev about performance and caching. You've got the knowledge now to not just answer the questions, but to explain the why behind your answers. And trust me, that's what's going to impress them. That's what they're really looking for. You're ready. Now go crush it.